for Glenda, like those people, this is a series like for a whole like gap or something. Yeah. So aren't we disadvantaged? Last year, she taught us.
No.
I'll give it to Bonnie. Bonnie,
Right?
so you have an okay?
Today we'll do arithmetic sequence. There are some bits and topics we have to do a little bit earlier, like sigma notations and trivial things. But I think that you can very much do it in your school. Doesn't matter if good school, good teacher. You can do that. Those simple stuff. So what I'll do today is I'll introduce a general idea, a general picture of the arithmetic sequence from the beginning, everything. Then we do a bit of practices, and after that, foreign students stay here, and student students go with June for more exercises. Okay, and our next term schedule is like this. Did you receive my second email, modified timetable?
So does that mean we have a holiday?
We do.
Well, how many weeks?
In total of 3 weeks. So just quickly introduce it. So next term, our class will start about 7ish or 7:15, depending on what time you can come. And at the beginning, we will have test. I always emphasize, but just a few times had it, but from next term, definitely everywhere, we will have a test on the previous topic. But short one or two questions, 10 or 15 minutes, but every week. And then we will have 3-unit class. And what's next? Then we'll have a 3-unit back class tutorial. And in parallel, those 4-unit students have videos or some other activities. They can join here or they can watch videos. But most of the time, they watch videos. So I'll give us some preliminary materials to watch it. And then we have a 4-unit. Then what about the 4-unit students who didn't do this, who need it? And as I told you before, I'll discuss individually and I'll make a decision. There will be another 3-unit class that we locate somewhere. Depends on when you are available. If your topics are really different from what I'm doing it. So you can attend, those students can attend 2 classes. And also for 4-unit students, they definitely need a tutorial time for that thing and that thing as well. So most likely I try to Thursday, one there, and Saturday, depending on our situation, I'll put it on that. So that does not mean 4-unit students doesn't have anything further commitment. They have to do, attend somewhere. And next term, our tutorial will be more intensive. Rather than just let you go as you go, we'll actually hand out some printouts, like hand out some questions that related to my class, then actually go through it. Okay, so the timetable, this is clear. Other things are bits and bits, but remember, 4-unit students have to attend somewhere, either here or here, depending on our configuration. But I always emphasize that Thursday will be the best one. But I might make another session as we did before. It's a Saturday, and also 3-unit students. Some of the schools 3-unit we need extra supporting classes.
Can this Thursday tutorial be a bit earlier? This is starts at 5.
That's I punched all the different cases. Let me know. But it's hard to just fit everyone because sometimes someone need earlier, someone need later, or something like that. So.
Maybe like 4:30.
But we'll see how. Also, the tutors availability is also another factor. So. And if you are seriously attending and you need more exercise, probably I can extend the Thursday maybe from like a longer hours so you can have more alternatives.
So when's that 2-unit?
2-unit and 3-unit classes you're sorting out.
So there's no separate?
Yeah, that's 2 and 3.
Also 4-unit people don't know that.
That's exercises. So Or for instance, they'll find some other time, sometime. Okay, so arithmetic sequence. And final checkout. Who completely finished the sequence and series? 1, 2, 3. Not in the back row. Right. So arithmetic sequence. What arithmetic sequence is? Arithmetic means addition, isn't it? Addition. So arithmetic sequence means there is a certain sequence. Okay, those who finished it. What's the difference between sequence and series? Something is a sequence, something is a series.
Do they ever overlap?
Sequence is like one thing. Series like addition.
Yeah, that's right. Sequence just is arrangement. Sequence is 1, 2, 3. Series is addition of sequence. Sum of the sequence. That's the series. Okay, that's a sequence and that's a series. Sometimes sequence we call the progression. Arithmetic sequence is something, there's an initiating number, for example 3, and then next term will be obtained by you adding a constant number, a fixed number. So if you add 2, there are 2 numbers. And at this stage, you can't say whether this is arithmetic sequence or geometric sequence or harmonic sequence. There are many different sequences. You can make it up. As long as there is a specific rule, there is a sequence, new sequence. But by doing that, we don't know exactly what is the pattern, because we don't know whether this is added by 2 or multiplied by 5 and 3. We don't know. So we have 2 terms we don't know. But if that is arithmetic sequence, that means the terms are adding, obtained by adding certain fixed number. So if it is arithmetic sequence, then what's the next number? 7 and 9, going like this. Okay? Then, do you think this is an arithmetic sequence or not? Yes. Why? So, you added 0. So this is still arithmetic sequence. So arithmetic doesn't matter what number it is. What about this? 1, root 2. Then 1 over root 2. 1 over 2. Can it be an arithmetic sequence? No. What type of pattern is it?
It's going like really small then a bit bigger.
It's geometric.
What's the pattern? You multiplied 1 over root 2 from here to there. So rather than addition, this is multiplied. Constantly multiplied. That is a geometric sequence, which is not part of this. Okay? What is geometric means multiplication, arithmetic means addition. What about this? Log 2 square, log 2 cube. Can this be an arithmetic sequence? Yeah, Bonnie? How? What's the difference between this? Log 2. You add it because if you expand it, it's log 1. 1 log 1, it comes out, it's 2 log 2, comes out 3 log 2. So that means you are adding log 2, log 2, log 2. So that means it is log 2, 2 log 2, 3 log 2, which is similar to what? Similar to x, 2x, 3x. So what happens? You are adding x. This is also arithmetic sequence. Okay? And you say sequence, not necessarily just a number. It could be anything, any geometrical, any.
Negative number?
Yeah, of course, doesn't matter. Even complex numbers if you want.
Oh, because last week when June was telling us, he was like, it can't be negative.
Probably someone I'm sure you shouldn't know. That's not that. So anything, negative number, positive number, log, whatever, letters, x, y, a, b, alpha, beta, pi, whatever, as long as added a constant amount, that's arithmetic sequence. For example, this is arithmetic sequence. Then what about this? X. Can't think of anything interesting. 2x minus 1, 3x minus 2, 4x minus 3. Can you please arithmetic sequence? Yes, what's the difference? So if you are suspicious of arithmetic sequence, you only need to check twice. Check the differences in two different positions. What's the difference? X minus 1. Isn't it? You added x minus 1. And what's the difference? X minus 1. Yeah, it's arithmetic sequence. Okay? So in that way, when you define a certain arithmetic sequence, we only need your two informations. Which means, first, where does it start? What is the number added? Then,
Once you need to know where it starts.
So, initial one. That's called the initial term. Term 1.
How do we find that out?
So, what I mean, if it is given, so we only need two pieces of information to clearly identify what type of sequence it is. Starting term and the addition term. How much is added? But in some different questions, they give you in different ways. But important thing is we need only two informations. So sometimes they give in this way. I have a certain, I think that's case 1. They ask some question, find blah, 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 blah. It could be anything. But given information must be two pieces. Someone says, the initial term, A1. Sometimes it says A1 is initial term, equals 2, and D. What's D? Difference. So addition term is 4. And find something. This is complete information. You know the first term, you know the difference. Imagine, you know the first, you know the difference. You can generate everything. You can find the sums and terms, whatever. But some other ways, they might give you exactly the same information. They say this. Again, of course, it didn't give you clear idea what's the initial term and what is the difference. But still, from this, you can completely describe the nature of this sequence. What's the difference? What's the difference? 2, isn't it? Well, how you find out 2? Because when you get from here to there, how many times do you have to add? Twice. 4, so A3 and A4, A5. So you add once, twice. So that's difference, that's difference. So total difference will be 2D. So you added a certain number twice, and you add it up 4. So you're adding every time 2. So D equals 2. There. Third term is 6. Third term is 6. The difference is 2. What's the second term? 1 before. 4, isn't it? And 1 before. 2. So this is A3, A2, A1. So initial term is 2. So this is initial term is 2, and common difference, called common difference is 2. Then you can find everything. How? We'll learn it. So everyone get the idea what is the arithmetic sequence like? Then we'll go a little bit further. We have one arithmetic sequence. His name is called Jenny. The sequence name. Who's Jenny here? No Jenny here. So, but let's call it, her name is Jenny, sequence name. Jenny 1. Jenny 1 is A, which is the first number. Jenny's difference, which is D. Okay, so this assembly sequence, initial number is A, and you are adding D. So now, I'll ask Bonnie, what is seventh term in terms of A and D? A plus 16. Easy, isn't it? The seventh term, how many times you have to add it to get there? 6 times. You're starting from 1, 2, 3, 4, 5, 6, 7th term. Obviously, that one, you don't add it. Second term, you add 1, 2, 3, 4, 5, 6. So, 7th term is first term plus 6 times of the addition. Second sequence name is Kate. Use Korean name? Chinese name? Zhao? Zhao sequence. The reason I'm using that name is, there are some, if you study math more in uni or whatever, sometimes you came up with a very special sequence. They usually give a certain name. Who's the sequence, blah, blah. So you give them names. Zhao sequence. There's a very special sequence. It is very special because its initial term is, say, minus 10. And common difference is 5. Okay? We like to know. So that means that Zhao sequence is wrong.
Oh, that's right. Oh, bad. What?
Zhao sequence start from minus 10. Then what's the second one? Minus 5, because adding it. Then, so first one, second one will be minus 5, third one will be 0, keep going, blah, 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 blah. Then, the question is, what will be the 992nd term? What will be the answer? Minus 10 plus, how many times you have to add it? 991. So it's 991 times 5. That's the term. Easy and very peasy, isn't it? Why?
Easy peasy.
Easier and peasier.
Easy peasy. It's like, oh, it's really easy. Oh, it's another
Okay? So,
Is that?
we have another sequence. We have another sequence which name is Janet sequence. Janet sequence. Janet sequence, it starts from minus 250. And it increases by 3, 4, 7. Make it easy, harder, 11. So that means the first term will be minus 250. And what if the second term? Second term will be minus 250 plus 11. So that will be 139. Now here comes typical 2-mark question. Find the first term, first positive term. Let's leave it later. We did a little bit more. We'll get there. Okay, write down. First positive term. We have people. Have a look. There's another sequence. Jenny. John's sequence. John. Huh?
Jane.
That was my computer.
John's.
The HS. The OHN. J or
King's sequence. You don't like King? Queen's sequence. No, Queen's sequence name. That sequence, the initial term equals x. Huh? It's x, not number. Common difference is say z. They want to know
What?
case. First term is x, common difference is z. What is the case term?
I don't really get that. Oh, I thought it was a K plus H plus term.
No, case. Case.
I thought it was KTH plus O.
Okay. Eric.
I thought it was K plus H.
So, Eric, what's the answer? Okay, x plus k minus 1 times z. Right? So, we definitely have a, right? What is it? Baseline. And we're adding how many times of z? K minus 1 times. If it's a 100th term, you add 99 times. If it's k's term, you add k minus 1s. Then what about, in this one, what about k plus n's term? What do you do? Same thing, isn't it? So you add x and add z, how many times? K plus n minus 1. Okay, getting the idea? Okay. Arithmetic sequence, the reason, did you notice that today's my approach is slightly different than usual? I going very, very detailed and simple things. The reason is, sequences itself is actually very easy. You can do, if you practice a little bit more, you can solve all the questions come to unit. But in application side, which is application, what is it? Induction and money finance, and it happens in some applications in any type of question 3 and 4 unit. So you should have a very clear insight. Should not make any mistake. That's why I'm going very detailed. Now, so in this case, find nth term, Genesis sequence. What's the Genesis sequence nth term? Then we start from the beginning. And how much do you add? 11 for each of how many times? n minus 1. What is the name of this? an. Usually it's nth term, we say an. Some textbooks say tn. What's tn? What does t for? Term. Okay? Some people use tn, some people use an. Doesn't matter, it's the same thing. And usually when it becomes n will be any term, isn't it? You can put any number. So sometimes you call it as general term. So the formula for nth term is sometimes called general term because it's generalized term. Now, we get to the 2-mark question here. That in this genesis sequence, question is find the first positive term. Then in the first positive term, how can you do? You say positive, that means AN is positive. So you solve it. So minus 250 plus 11 n minus 1 is greater than 0. Then you 11 n minus 261 0. So n is greater than 261 over 11, which is how much? How much would that be? Should I divide 261, 11, 20?
3 and 8, 11.
Something. So that means, let's think about this. Then that means we have to consider A23 and A24. Is this one positive or negative?
Negative.
Negative. Why? Because 23 is not the answer for this. So it's not satisfied this. So that means it is negative. 24 satisfy this. 24 is bigger than 23 point something. So it will satisfy this, which is positive. So that means positive. So first positive term will be 24. Another one. Name. My name is too precious to use that one. I'm okay, but other doctors would be happy. As the sequence. As the sequence. Twelve is minus 20. Thirty is 100. And then they ask to find.
First positive term.
Huh? Which one?
First positive.
First positive. First positive. Okay, first positive. Last negative.
Last negative. Oh, you mean
So, to find last negative, the easiest way, whenever in that kind of question, easiest way is from two pieces of condition. Definitely they'll give it two pieces of condition. You find the first term and the difference. Then put the general term and say this is negative. And that'll do. So, how can you find A and D from here?
12 plus.
That will be, what will be the, so we don't know A and D. What will be the expression for the 12s in terms of A and D? It will be A plus how many D's? Janet, how many D's? Huh? Because it's 12s, how many times do you have to add it up? 11 times. First term, how many times do you add it up? No addition. Second term, how many times do you add up? Once. Third term, twice. Third is, first term will be A. How many times do you have to add D to get the 30s? Yes, 29. What is one less? 29D. Equals minus 20 equals 100. Then can you find A and D? Yes, easy. How? See, that's very easy. Subtract. Subtract from here to there. then 18D will be 120. Then D equals something. I'm too hot. Can you turn the...
What temperature? Pretty hot.
Closest to negative.
There's taste.
That's 20 on 3.
What is this?
20 on 3.
That is
20 on 3.
20 over 3.
6 and 2.
Huh? 6 and 2/3. Okay, leave it there. And if you put in there, then you find A. Then A will be, you put it here, 100 minus 29 times 20 over 3. Then, what's the last term?
When you tell us to find a bigger term.
Yes, that's what we needed. So we don't know what is the last term. We don't know which one is the last term, but you can give him a name. Say 1 plus, if the last negative term is nth term, what will be his expression? What's her expression? n minus 1d, isn't it? Because if assuming that is nth, the expression for the nth will be first plus n minus 1d, which is last negative. So what should you do? You can solve it by positive or negative. So it is negative. Then you put it in these numbers. A is 100 minus 29 times 20 over 3 plus n minus 1 d. What's d? 20 over 3. Then you can solve it.
The last term. Isn't it the first term?
Last negative. Because it will start negative and going less negative, and suddenly become positive. We want this one.
Can you just find the first positive and just subtract one?
Yeah, of course. In this case, you can solve this way as well. So just interpretation of your calculation. Okay, this is arithmetic sequence term like manipulations. They are always interested in the series. What is the series? Series is addition of it. Addition. There's one question, very common question. We have 10 and 257. We have two numbers. Huh?
Is that a sequence?
Yes, it is a sequence. But we have two numbers. Two numbers. But someone, I'm sure, very unusual person, quite bored. They want to put certain numbers here between them. 1, 2, 3, 4, 5. So how many numbers in total? If you put additional 5, 7 numbers. They want to make a sequence starting from 10 and at 257 with a total number of terms of 7. Find the numbers. So that's what they are saying. If you go to easy one, same question, we have 10, we have 20. They want to put 3 more numbers, 4 more numbers to make arithmetic sequence, which means all the gaps are same. Find the numbers you need to put it in. Then that's very easy. To get here from here, how many D's are there, Esther?
There's 5.
Yes, because there are 6 numbers, the number of gaps will be 6. See? With 2 numbers, number of gaps are 1. 3 numbers, number of gaps are 2. So that difference is made up of 5 differences. 1, 2, 3, 4, 5. So 5D, isn't it? So 5D will be what? 20 minus 10. So D will be 2. So that means what's the next number? 12, 14, 16, 18. This is also very common 2-mark question. Then I'll give you another question. Today is very primary school style. We have
Can we do something?
this one. It's very simple. How many terms there? 1, 2, 3, 4, 5, 6, isn't it? So there are
Isn't that 7 terms?
7 terms, but the gaps are 6, isn't it? So by adding such number 6 times to 10, you get 257. So what's the gap here? It's 247. Is equal to how many numbers? 6 times of difference. So D found. I'll give you one question, and now first time you do it yourself. You have a number called x and y. X, y is the number, which is multiplication. You have a number. Should I do it or not?
Yeah, let's do it.
That. And I will make a arithmetic sequence of 4 terms by adding 2 numbers between these two. What are the numbers? Huh? There are one number and second number. We want to put 2 numbers between them to make it as arithmetic sequence. So that means the gaps are exactly the same. Find the 2 numbers. Oh, you've done it this? So what is the gap?
Z minus xy on 3.
Z minus xy on 3. Then you add it. Continuously add it.
Can you take it away from there?
Yeah, of course. You can do. Yeah, same.
Oh,
Okay, next one.
When we did it with June, it was really the same.
Huh?
Last week when we did it with June, that's because it makes everything so complicated.
Right, next one. So, now our interest is finding series, not term, the sum.
Finding a series.
You can understand this way. The nature of arithmetic sequence. Arithmetic sequence, E starts from A. As term goes, it increases, but how much is increase? Simple number, isn't it? But it's a fixed number. So if you graph it, if you kind of graph it, it goes by straight line. So it's gradient, increase by a certain number, 2, 2, 2. So it's a gradient. If you understand this, it is very easy to make up your formula for sum. So what it is, because they are in the linear, they are exactly symmetrical. If this is a middle number, average number, then this one's a little bit less, this one's a little bit more. So the average is a real average. So the way you calculate the sum, okay, let's say it this way. In your class, you have 10 students. The exam average is 50. What's the total mark?
500.
Did you get it, everyone? You have 10 students, a class have 10 students, average score is 50. What's the total score? Huh? Rosie? 500. Because that average is a really average, simple average, isn't it? Same thing.
But it might not be.
Why?
Oh, so does that mean everyone got 50?
I mean total. I'm not saying it's everyone. It's total mark. Total mark. So that's the one way. So look at this. If one class, of course, I'll give you some other ways too. If you have a class, average mark is 70, number of students are 20. So what's the total mark of that class? 20 times 20. So if you know the number of people and the average mark, it's easy to calculate whole.
What does that have to do?
Okay, so but this makes sense, isn't it? That makes sense. Look at this. Look at this. For some people, it will give a very clear idea, but I'll explain other ways in the textbook ways, that's formula ways. Imagine, think about the fact that arithmetic sequence, they are increasing very regularly, isn't it? They are not like this. They are regularly increasing. So we have one arithmetic sequence, the starting from 10, and we don't know how many terms are there, but they are really regularly increasing. Last term is 110. What is the average of these terms? Average of this whole term? That's exactly middle, isn't it? Because they are exactly linearly progressing.
It occurs at the middle.
Yes, so what's the number? What's the average number? 60. 60 is the average.
60.
60 is average.
Why is 60 the average?
Midpoint. Add them, divide it, midpoint.
But what happens to the 0 to 10?
Oh, you don't have it. So the question is, we have a certain sequence we don't know, which starts from 10, and at 110. We don't know what's happening here, but we know it's an arithmetic sequence. Then doesn't matter how many terms. That's because they are like linearly increasing, the average will be 60.
The average curve or is 60?
Is 60. You don't know. If there's 4 terms, that should be the term.
So, but isn't the y value the average and not be like x?
Don't worry about this. Don't worry about this. But just think about this way. Numbers are increasing regularly. Then take the average. What's the average? Don't worry about it. Just average is the midpoint. Average is the midpoint. Then later on, we realized the total number of terms are 10. 10 terms. So concentrate once you understand that theory, that opens up certain ideas in very awkward situations. We could go easier ways, just knowing this much. Again, the situation is that we had a certain sequence starting from 10, ended 110. The number of terms are 10. You want to know the total sum of the sequence. What's the total sum? Then the easiest way is, because this is, the regularly increasing, we take average, 60, same as class average. As soon as you know the average, times number of people. That's it. So what's the total sum? 600. Think about your class. Your class average times number of people is a total mark, isn't it? That's very simple. Nothing more than that.
June told us the other way of going.
Don't worry about the June. Just concentrate on what I'm saying. So it's a clear idea. Clear idea. So then we come up in this way. So we have a clear idea. In any sum, not just a sequence, any collection of terms, numbers. One way of finding the total sum is if you know the average and know the number of terms, that's fine. Average times total number of terms. Isn't it? But good thing is, in arithmetic sequence, it is very easy to find average. Average is exactly midpoint. That's the point. Later on, we do the geometric sequence. In geometric sequence, you can't find average. Very hard. You can't. Logic? So my point is, in arithmetic sequence, it is very easy to find average. So I will memorize the formula for sum by using the average times number of people. Now, I'll show you formula. Then the formula will be exactly the same as what's in the textbook. That will be very simple. We have sequence, arithmetic sequence, started from the A. And it goes on and on and on. And nth term, what's the nth term? A plus n minus 1d. This is the nth term. So how many total terms? N is the total terms. What's the average of these?
What n total terms?
What's the average of the total sequence? In arithmetic sequence, they are balanced. Average is very simple. Just average of first and last is the average. So what's the average? A plus n minus 1d divided by 2. That's the average. Then what's the total sum? Times n. If you look at the textbook, they will give you answer as this. That's how you get this formula. Make sense? Sometimes we use that formula. In textbook, they'll give you 2 different formulas. One is this. One is a plus n divided by 2 times n. That's another formula. What it's giving is the first term and the last term, average, times number of terms. That's the formula for sum. Either you use this one. If you know the first and the last and number of terms, that's easier. If you don't know the last term, but know the first term and the difference, then that will be easier.
So if you follow that, shouldn't it be 2a plus L?
No. L is the last one. But the last one is a plus n minus d. Okay, so A plus A. This is the last one, isn't it? I think if you concentrate, you should get already have a clear idea what the formula for the sum. But why we can't use that for other sequences? In other sequence, what's different? It was difficult. Difficult to find average. Average in other sequence, complicated sequences, we need a sum to find average. But arithmetic sequence, this average is the same as average of the first and last one. Huh?
Oh, no, I get it now.
Right, yeah. Because the thing is this. In other sequences, find the average is hard. In arithmetic sequence, find the average is easy.
Are there only two types of sequences?
I told you, there are many times you can make it up. Any rules there?
In geometry.
Yeah, that's the common one
Two types.
in your exam. But could be something else too. Named one is arithmetic and geometric. But there are some other questions can come up without name, just giving the formula.
In 3-unit?
2-unit and 3-unit. But again, these are application is more important. Application is more important. Okay, what time is it now? Yeah. So what's the now you can write down now. So what's the sum formula for when you say sum? We use S. Not this, but their meanings are exactly the same. Sum. What does that mean? Sum of n terms. What's that?
10, 10.
More specifically, sum of 1 to 10. Okay? 1 to 10 equals sum of 1 to 10. So in an arithmetic sequence can have, that's the formula. Average number of terms. You can make average in the other way. First term plus last term. Of course, you can pack as 2A. 원이 나면 familiar? So we'll do primary math once again. We have one sequence. First term is 5. Common difference is 10. Number of terms are 25. So that means the sequence goes 5, 15, 25, 35, 55, until when? What's the last one? What's the last one? What will be the last one?
5 plus 24 times.
Yeah, so 255. You know, sure, 255? 245. Why? Because the last one, which means A25, will be first term plus how many times do you have to add? 24 times of 10, 245.
Would we finish?
When I like to. So the question is, people look at this. People they're asking S10. That means what?
Sum of the first 10 times.
Yeah. So that means it's adding from the beginning, isn't it? So what is the answer for it? So you're taking average. So average from, yeah. So first term is a 5. What's the last term?
How did you know the first one was 5? And up.
And the last term will be how many times you're adding? 9 times, isn't it? So 5 plus 9 times of 10. That's average. And times?
10.
10. That's the answer. In formula, they'll say 2a plus m minus 1 d over d times 10.
But it's better doing like that, right?
But not better, exactly the same thing. Exactly the same thing, isn't it? Exactly the same.
Like, do you understand?
Okay, Rosie, your turn.
It's running out.
Rosie,
Last week.
they're asking sum from 11 to 20.
Can you say that? Will they ever say that?
They may or not. They usually,
Is that actual notation?
I can't guarantee. But as far as I know, there's no formal terms for that middle term. They might say, find the term, sum of the term between 11 to 20. They might say it, but I'm not sure it is. But they understand
I
that.
mean, if you wrote that in a text, would you lose one?
I don't think so. As long as the following questions is correct, it's okay.
Or we can say like 11, like 10, 11.
Later on, you will use this because you haven't done the sigma yet. Yeah, k equals 11 to 20 and a k. Then that's the same thing. But we'll do later. Okay, that makes sense. Anyone did a sigma? Yeah. But don't worry about this at the moment. That's our communication, easy way. So, Rosie, so how you do this? You don't need to answer the final answer. You just tell me how you do it. Huh? There's a shortcut. Think about. There's a shortcut. Wani? Shortcut. Tell me the shortcut.
Me too. Is it?
The formula we know for the sum is all the formulas are from 1 to somewhere, isn't it? 1 to somewhere. But this is unusually asking 11 to 20, isn't it? But if it's anything from 1, we can calculate it. Make sense? So when they ask the between sum between certain sum, do it. Make sense? Yeah. Then you can work it out. Huh?
If you didn't know S10, it would be exactly the same.
Yes. So anyway, we can calculate. All right? People clear?
Yes. So like.
Then I'll ask another question. Is it for ready?
You're finding the sum from 1 to 20, right? So if you find the sum
Ready?
from 1 to 10,
What will be the answer for this?
I don't get this.
This is very important one. Remember, this is very important.
okay, I should do this.
Sum up to 11 minus sum up to 10. What's the answer for this? Ready? Huh? Yes, shortcut. You know the shortcut. What is the significance of this?
It's just T.
That's one. Which one?
T.
11, isn't it? So some difference from up to 11 and up to 10 is just adding 1. This is very important. This is very important question. The reason I'm saying that one from the previous question to this is, I'll explain that. That question, if comes, is 4 to 5 mark question eventually. So which means our common term this question is a type of question which determines your partner. 5 mark can change your partner. Maybe Esther will be more understanding in this way. Make sense? See this? This is easier. But you should understand this way. Okay? Sum up to 11 minus sum up to 10, left to right, the new term. Okay, here, people, I need attention. People, you are getting to start for 5 mark question.
Can I see?
Then what is the 5 mark question? That is this. They give you a formula. They will give you a formula for sum. Not A, not D, not N. They give you a formula for sum. For example, this is n squared plus 2n. And then they ask you to find an.
A-N.
Yes. Then what's an? From Sn. Then that is Sn minus Sm minus 1, isn't it? From sum up to m minus 1, you added an to get Sn. So that's the difference.
I still don't get that. Oh my god.
You can already rearrange it.
I don't get that. I still don't get it.
Okay, in this way. Okay, this is special for Esther. Esther, until yesterday, your pocket money get from your mom is.
I don't get pocket money. Anyway.
Okay, then you. Okay, then who's gonna be victim? Okay, then Simon. 4 months until yesterday, you get pocket money of $100. Okay, you get pocket money of $100. Okay, and until yesterday, your total pocket money is $100. Until today, it's $120. How much do you get today? 20. That's this.
Well, what's the A? Oh, so it's not the average.
Yeah.
I get it now.
That's very easy.
I get it.
That's grade 1 question.
Wait, I don't get it.
Don't worry.
I don't get it.
So you can that one? So concentrate. So we using it. That's not the end of story.
I get it.
Be quiet. That's not the end of story. This the more important part. The more important part coming. So that will be Sn is n squared plus 2n minus
A-N.
m minus 1 will be, use that formula, m minus 1 squared plus 2m minus 1. Okay? Just substitution. Then you get, if you expand it, n squared 1, what do you left with it from here?
Minus
2n minus 1. And from take away from here to there, you get, what did you get?
0. And
Plus 2. So 2n plus 1. Correct? You get 2n. So an is 2n plus 1. So if you leave it like that, how much do you get? How much mark? If it's a 5 mark question,
Oh, I get it.
3 out of 5.
Wait, I don't get it.
Yay!
Oh, yes, I get it.
If you leave it like that, if it was a 5 mark question, how much you get?
2 marks.
3 out of 5. Where is the 2 mark gone? It's not finished yet. What did you say? A1.
What? Why do you need A1? Is it fun A-N?
The reason is this. Can you say A1 equals S1 minus S0? Can you say that?
Yeah.
No. Sequence series, there's nothing called this. So rather, so that is only for from 2. A1 is what? A1 is S1. This is more correct, isn't it? A1 is a sum of up to 1. They are same. So that formula works for all other terms except the first one.
This is the hardest topic.
If you can't understand, just memorize. Because in that type of question, they won't give you any other type. The exact formula, like induction. If you have done induction, it's just formula. If you just follow the pattern, so for you have to add it. For n is 2, that is blah blah blah. For n equals 1, a1 equals s1. That's what you have to do. Then s1 will be 3. Okay?
Then you get 5 marks.
Then you get 5 marks. Frankly speaking, you can get 5 marks, or if your examiner is really bit crazy, you may get 4.5.
Why?
Because there's one thing that you could more.
A0?
I mean, there are additional things you could do. Then, in my opinion, that's perfectly okay. But you could do better, but I won't give you any extra mark. But some people will give you extra mark. We're comparing. That formula, does it work for this case? Yes, same. If you put n equals 1, it's the same answer. So, equals 2n plus 1. Therefore, rather than maintaining 2 different formulas, we can make one formula. Therefore, Sn equals 2n, an equals 2n plus 1 for all numbers.
That makes sense. I think you should lose a mark if you don't write that.
Yeah, I appreciate it. But remember, but not always the same. Not always same. So that means if you just leave it there, doesn't really matter because sometimes they're different. Sometimes you need 2 different formulas, but sometimes they are same, applicable. Then you have to check whether they are applicable. Then it's applicable. Then you make a combined one single formula. That's perfect. Okay. So if you think of your very weird examiner, and if you think of your who's the weird one, yeah, they could mark off this one. If you could do more, but if you just leave it.
This is Doyle. I don't like this one.
Yeah, Miss Doyle. I love
So in summary,
Yeah, she is.
John, okay, attention please. Do you think that method works for arithmetic sequence only or geometry sequence as well?
Only geometry.
What do you think?
Only arithmetic.
What do you think, Wani? Both. When you're doing that, you haven't used any idea of arithmetic sequence. It's a general. Whatever sequence, sum up to here minus sum up to here is left over here. Doesn't matter. Geometric, arithmetic, whatever sequence it works. Do you understand? Can you understand? That one, this method can be used in any sequences, any series. So we'll do one practice. You do by yourself, by your hand. We given certain formula, which is 2n squared minus 3n plus 1. Find the an. 해볼까요? 20 minutes? 20 minutes. 20 minutes break.
Oh,